A giant window is to be built using 1,200 meters of steel. The window will be in the shape of an equilateral triangle over a rectangle. We want to know what dimensions will let the most light shine through. We also want you to suppose that the triangle is to be tinted so that only half as much light per unit area shines through the triangle. And then we want to know what dimensions will let the most light shine through. So in other words, in that second part of the question, although it's not in the wording on this sheet, what we're saying is that the top part of the window will be tinted, and so only half as much light will shine through that part. Okay? And it says here we can round our answers to the nearest tenth of a meter. So what we do is we begin our solution by letting the three parts of the equilateral triangle all be W. And then we notice, of course, that the bottom part will equal W as well because it's part of a rectangle. Then we also notice that the two other sides of the rectangle will both be X. And so the total area is going to be the area of the rectangle times the area of the rectangle plus the area of the triangle. The area of the rectangle is clearly x times w. The area of the triangle is 1/2 base times height. Now we have a problem here because we have four different variables in our area formula, and we need to convert them all to one variable. Well, in this case, we're going to convert them all to the variable w so that we can give an expression for area in terms of w. So we convert x, b, and h to expressions involving w. Now, in order to do that, we do a couple of asides from our typical solution. The first one is to convert x in terms of w. Well, we see that we have 1,200 meters altogether, and that means 4w plus 2x equals 1,200. We can then isolate the x, and what we get is 2x equals negative 4w plus 1,200. Divide through by 2, and we get x equals negative 2w plus 200. Next, so we have an expression for x in terms of w. Next, we notice that in terms of the equilateral triangle, our base is simply w. So instead of saying 1/2 base times height, we can say 1/2 w times height. Finally, we have to get our expression for h in terms of w. In order to do that, we're going to cut this triangle down the middle vertically, and we're going to have this triangle here. So in other words, this is, if you cut this triangle here down the middle vertically, you get this triangle here. And since it was an equilateral triangle to begin with, we know that this has to be a 60-degree angle and this has to be a 30-degree angle. Well, using some trigonometry, we know that the height of that triangle will be cos 30 times w, which means that the height is actually root 3 over 2 times w. Now we can go back to our original formula, and we can sub in x equals negative 2w plus 600. We can sub in that h is root 3 over 2 times w, and we can sub in that the base is w, so 1/2 base times height. Now we're going to begin our rounding here, and we have negative 2w squared plus 600w plus 0.433w squared. We collect like terms in the next line to get negative 1.567w squared plus 600w. And next what we're going to do is look for the axis of symmetry. We have an axis of symmetry at a w value of approximately 191.45. So that means that our maximum area will occur when the w value is approximately 191.45. Now in this case, had we carried more decimal places throughout, we would realize that we need to, the w value is actually slightly greater than 191.45. So we're going to round our value for w up to 191.5. Now if the w value is 191.5, the x value is negative 2w plus 600 from earlier in our solution, so x must be 217.1. Okay? So that would be the dimensions that lead to the greatest amount of light shining through. Now part B asks, well, what if the top part is tinted so that coming through the triangle we only get half as much light as we did earlier? Well, in that case, we can make an expression in terms of the total light. The light total is equal to the light coming through the rectangle plus the light coming through the triangle. And it's the same formula that we had above, with the exception that we're going to multiply the amount of light coming through the triangle by 1/2. So what we do is we keep the formula for area of the rectangle intact. We multiply the expression for the area of the triangle, which is right here in black. We multiply that by 1/2 because only 1/2 the light is coming through. And then we begin rounding with decimals, and we get an expression that the light coming through in total is equal to approximately negative 1.783494 W squared plus 600 W. At that point, we find the axis of symmetry. We get that W is approximately 168.2 and X is approximately 263.6. So that means that under these new conditions, the maximum light let through will occur when the sides of the equilateral triangle are each approximately 168.2 meters, and the sides of the other sides of the rectangle are 263.6 meters.